This is Lab 6, Activity 3.1, Ohm's Law. And we have a new device. This is our variable DC power supply. DC does not mean District of Columbia. It means direct current, and that's the same kind of circuit that a battery provides. So this is acting like a battery, except that I have a little dial where I can increase or decrease the voltage. Notice I have a red and a black clip. Now with the color coding, we can see that the red clip is going to be at our highest electric potential and the black is going to be at our lowest electric potential. And the analogy that we've been using is that potential is you can think of it as a kind of pressure, that we're pushing more charges into this part of the circuit, increasing the pressure of that electron gas, of those charges that are in there. And here we're pulling electrons out of that part of the circuit, making it a lower pressure. And then the charges that are already in the circuit are then going to be circulating through anything that has a resistance. In this case, it's going to be a resistor for 3.1. If you have not already made your predictions on page 117, pause your video and make those predictions now. Okay, before we collect data, we want to make sure that our equipment has been calibrated. I've got a current sensor measuring current in the circuit, and there's only one pathway for the charges to circulate. So if I measure the current there, I'll know the current everywhere in my circuit. And I've got a voltage sensor ready to go into it that I'll be attaching here once I've made sure that these two clips are reading, when they're reading in the same spot, reading the same amount, the difference, the voltage should be 0. Right now, my screen shows that the voltage, it's getting a reading of a couple hundredths of a volt, and the current less than a thousandth of an amp. But I'll go ahead and zero both of those. Hit OK. And now our voltage is to within a few thousandths. I'll have to look at that, less than 1,000. So it's actually less than 1,000th of a volt, close to 0 now. So that's incredibly close to 0. I'm going to attach the red clip to the higher potential side and the black clip to the lower potential side, so it'll measure the potential difference, the voltage across this resistor right here. And then I'll turn on the power supply and gradually increase the voltage. Okay, so I'm going to start collecting data. I've got about 30 seconds. That's more than enough. Collecting data now, and I'm going to take this little dial and increase it gradually up to 3 volts. Oh, there we go. Starting to get a little bit of a reading. Oh, and I just noticed that my Logger Pro stopped collecting data at 10 seconds. So what can I do? I'm going to go into here, into the data collection. And there's a little shortcut if I click on the time button. And I'm going to increase the duration from 10 seconds to 30 seconds. So it'll give me a little bit more time. And I'll hit the space bar again after I've gone back down to 0. Here we go. Take 2. Collecting data, gradually increasing the voltage. Now this dial that it reads here gives me a sense of what the voltage is at this source right here, but it's not, Logger Pro is not measuring that. Logger Pro is measuring the voltage across this resistor in the circuit. And I just went over 3 volts, so I'll just keep it there for right now. So we've got our first run with the resistor. We're ready for the next run, which is then extension 3.2, where I've replaced the resistor with a light bulb. But I want to insist that you pause your video now and fill out all of activity 3.1. This will be better for you to do that first before you move on to the next activity. So pause the video now, and let me give you a couple of reminders about how to do that. You have on page 118, you're making a sketch of the graph, current versus time, but then you're making a sketch of voltage versus current. And if we look at our graphs here, we have voltage versus time and current versus time. So you have to make that bottom graph a graph of voltage versus current instead of voltage versus time. Do you remember how to do that? If we put our cursor over that label, we can click on that, and then it'll give us some options of some other things to graph. So you'll need to do that for the run with the resistor so you can get a sense for what the relationship between the voltage and the current is. Then you'll need to use a fit routine, and you can access those by coming up to curve fit, or if you think it's a linear fit, you can use that. So there's some different routines that you can use to try the data to see what the best relationship is. So please take 20 or 30 minutes and answer all of those questions. If you want, you can watch the rest of this video another time for the extension 3.2. I'm going to collect data now. Collecting data. And actually, I should have had my hands the other way. I'm sorry about the shakiness. I'm going to start collecting data again. All right, so I'm going to be increasing the voltage. Don't see any. Oh, it's starting to glow a little bit. Keep on going up a little bit more. Go up a little more. And I'm about at 3 volts. And it's burning pretty brightly right there. So I'll go ahead and stop the data collection a little sooner than 30 seconds. And if we look at this graph, we have a sense of the shapes of the voltage versus time and the current versus time. But I believe you're going to want to change that second graph to voltage versus current as well for your extension. All right, good luck. The data files will be in our OneNote content library.